Hi, this video is to go over questions 1 and 2 on Standards Test 3 review. Taking a look at the first question, it says Marcus and Allie are arguing over which one correctly simplified the given expression. Determine if Marcus or Allie is correct and explain what the other did incorrectly by looking at their work. Explain how they should have corrected their work. If we take a look at Marcus, or at the problem, we can see that we should have to multiply. We've got a binomial times a binomial. When we multiply two binomials, we end up distributing twice. So we need to find the one that's correctly distributed. So it may be helpful to not look at either one of their work and just work out the problem. So if we work out this problem and multiply our first terms, we get 6. We multiply 3 times the square root of 6. We have to remember that you cannot multiply numbers that are not both under the radical or both without a radical. So we have one that's not under radical, one that is, so it's going to be just 2 square roots of 7. Then we multiply these terms. Because they are both under a radical, we multiply them together. So if we take a look at what we've got here so far, it looks like this here is correct, that Allie would have the correct work. So we need to state that Allie is correct. And let's figure out what Marcus did wrong. So he did 3 times 2, which gives us 6. Here he has the square root of 18. Oh, it looks like he multiplied 3 times the square root of 6, multiplying the 3 and 6 together. And that's not allowed. So what should we state? We should state something of the effect that Marcus should not have multiplied a number without a radical, or that it goes the same for saying outside of a radical too, with a number inside. So that's what he's consistently doing. He's doing square root of 7 times 2 is the square root of 14, and these are incorrect. So these terms here, he messed up on. Everything else is okay, but the problem's wrong because he multiplied those incorrectly. Next, for problem 2, for 2 through G, you're asked to simplify, so I'll go through each of these. All right. So the first thing we should recognize that this is cube root. So if it's cube root, that means we need to find groups of 3 of the same factor. So we can begin this by breaking it down using a factor tree. It's an even number, so we could divide by 2, and we'd get 2 times 54. And then that's also an even number, so that would be 2 times 27. 27 is 3 times 9, and 9 is 3 times 3. So ultimately, if you think about what we really have here, and I'm going to do it very explicitly, it means we have 2 times 2 times 3 times 3 times 3 times R 5 times, S 7 times, and T 9 times. You don't have to do this part, but I'm going to do it so everybody understands where, when we pull things out, where they come from. So we cannot form a group of 2 3s, but we can form a group of one set of 3s. So a 3 is going to come out. We can also form one group of R's, but these two do not form a group, so they stay. We can form 2 groups of S, so an S is going to come out and another S will come out, but that has to stay. 1, 2, 3. We can form 3 groups of T. Then we want to keep everything else under the radical. Please, you will miss the problem if you forget your cube root. So always go back and check. If it starts with cube root, your answer better have cube root. multiply any remaining factors. So 2 times 2 is 4. R times R is R squared, and we have an S. And then we just multiply anything left out here. So we have 3R S squared T cubed, cube roots. Notice I make that really big so we can put the 3 in there. 4R squared S. Then it'll be really clear that this cubed is not mistaken for the index of 3. And this would be your answer for 2A. Next, you're asked to simplify the square root of 50 plus the square root of 98 minus the square root of 27. So the rule is for adding or subtracting radicals, we have to have the same radicand, which means the number under the radical. So all we can do really at this point is simplify each one and see what happens. So 50 is 25 times 2, which is 5 times 5. Because we have a group of 5s, that comes out leaving 5 square roots of 2. For 98, that is 49 times 2. 49 breaks down to 7 and 7, forming a group. I bring down my plus sign, and 7 comes out with 2 remaining on the inside. Minus, let's see, we're going to have 3 times 9, which is 3 times 3. I can form a group of 3s that will come out, so we have 3 square roots of 3. At this point, we should recognize that these are like terms. Like terms are identified by radicals that have the same radicand, but when we add those terms, we do not add the radicands. We only combine the coefficients of those terms. 5 plus 7 is 12. So we have 12 square roots of 2, and this guy out here just has to come down here, minus 3 square roots of 3, and that's our final answer. For C, we are multiplying two binomials. We simply double distribute. 4 times 3 is 12. This should remind you of the Alley and Marcus problem at the top. 4 times the square root of 7 is positive 4 square roots of 7. We don't want to make that same mistake Marcus did. We multiply the inside, or multiply your inner terms. That gives us 3 square roots of 5. And multiplying the outer terms, the square root of 35. We should always check to see if we can simplify. If we try to break down 7, we just get 7 and 1. If we try to break down 5, it's prime. If we break down 35, we just get 5 and 7, each of those being prime. So there's nothing that we can pull out. So this is indeed our final answer. Next for D, we have a term on the outside being multiplied by a binomial, 2 terms on the inside. So we have to multiply these 2 terms together, so this term times this term, but that means we multiply the 4 and the 6 together to get 24, and then the 5 and the 2 together to get 10. And we'll do likewise here. Distributing the 6 to the 3 is 18. Square root of 5 times 3 is 15. We look to see if we do have like terms. In this case, we do not. That only breaks down to 2 and 5, which are prime. That breaks down to 5 and 3, which are prime. They are not like terms, therefore we are done. Nothing else we can do to simplify that expression. Next for E, we're multiplying 2 terms, but they have variables. So we want to break down our radicands into their prime factorization. 12 breaks down to 2 times 6. 6 breaks down to 2 and 3. We have 2 A's and 6 B's. 8 breaks down to 2 times 4, which is 2 times 2. We have an A and 5 B's. If we pull out pairs of factors, we're going to keep this 2, bring this 2 out, bring an A out, and 1, 2, 3 groups of B. Whatever does not get paired up remains in the radical. Now again, I'm going to bring down my 5. And I have a pair of 2's. And 2 pairs of b's. Square root of 2ab. Now if I multiply the outside, I get 4ab cubed, square roots of 3, times 10b squared, square roots of 2ab. I'm going to multiply the outside together, which I simplified first, but you could definitely multiply first. You'll still get the same answer. 4 times 10 is 40. A, got b cubed times b squared, that makes 5b's altogether. Square root, 3 times 2 is 6, and a and b. That we can form no more pairs of factors here, so we are through. So multiply first or simplify and then multiply. It's usually probably best to multiply first. That way, sometimes if you multiply what's on the inside, you could end up with pairs of factors. But as long as you end up pulling those out, you'll be okay. Next, almost through here. For f, you're just combining terms here. And you should simplify anything that could be simplified. Hopefully you caught on here that this is square root of 9 is 3, so that's actually going to give us the term negative 45. These two terms here are like terms, so if I combine them together, 13 plus 9 is 22, square roots of 10. But then I can combine my negative 3 with negative 45 to get negative 48. And at this point, 10, there's nothing we can break that down to pull out pairs of factors, so we're through. Let's see. Lastly, with g, we have 3 square roots of 7 over 3 square roots of 14. Or, I'm sorry, it's not 3 square roots of 14. It's just the square root of 14. To divide, we are actually going to have to multiply by the conjugate, not the conjugate, but the square root of 14 so that it'll disappear. But we are going to create a convenient 1. Meaning all I'm really doing is multiplying by 1 because the square root of 14 divided by the square root of 14 equals 1. So when we multiply this, the square root of 14 times the square root of 14, if you think about it, we can multiply those together, but that means we have a pair that's going to come out. So the square root of 14 times 14 is 14. But that's really the whole point behind rationalizing our denominator, is so that we get just the radicand. Up top, if we multiply these together, hopefully you recognize that if you multiply them together, you're going to have to simplify. So it's really actually best to go ahead and write it as 7 times 14, and then you can go ahead and simplify. 14 is 7 times 2. So you can multiply those together if you want, but then you'd have to do the factor tree and break it down, and 2 factors would be 7 and 14. So because I knew that, I decided to not go ahead and pull it out, or not to multiply rather. So the 7 comes out and gets multiplied by the 3 that's already there, and that gives us 21 square roots of 2 over 14. But recognize that 21 and 14 are both divisible by a common factor of 7. If we divide 21 by 7 and 14 by 7, we'll get 3 square roots of 2 over 2. So that's how you divide, by rationalizing the denominator. That concludes this video of questions 1 and 2. The next one will be on problem 3.